Hi everyone. Welcome back to Science with your channel name. Have you ever noticed how a straw looks bent when you put it in a glass of water? Or how your face looks different in a spoon? Today, we are diving into Class 10 Science Physics Chapter 10, Light, Reflection and Refraction. This is one of the most important and scoring chapters for your board exams. Let's understand how light behaves when it hits mirrors or passes through lenses. By the end of this video, you'll master all the concepts with diagrams and formulas. Light is a form of energy that enables us to see things around us. In ray optics, we consider light travels in straight lines. This is called rectilinear propagation of light. This property explains why we get shadows and why we use ray diagrams. Light travels at a speed of about 3 times 10 to the power 8 meters per second in vacuum. Reflection is the bouncing back of light when it strikes a polished surface. There are 2 laws of reflection. First, the angle of incidence is always equal to the angle of reflection. That is, angle I equals angle R. Second, the incident ray, the reflected ray and the normal all lie in the same plane. These laws are true for all surfaces, plane or curved. When light reflects from a smooth surface like a mirror, we get regular reflection and clear image. From rough surfaces like paper, we get diffused reflection. Plane mirrors are flat mirrors. The image formed by a plane mirror is virtual, cannot be obtained on screen. Erect, upright, same size as object, laterally inverted, left-right reversed. Formed behind the mirror at the same distance as the object is in front. Example, your dressing table mirror. Spherical mirrors have curved reflecting surfaces. There are 2 types. First, concave mirror. Reflecting surface curved inwards. It converges light rays. Used in shaving mirrors, dentist mirrors, solar concentrators, and headlights. Second, convex mirror. Reflecting surface curved outwards. It diverges light rays. Always forms virtual, erect, diminished image. Used as rear view mirrors in vehicles and security mirrors in shops. Important terms. Pole, P. Center of the mirror. Center of curvature, C. Center of the sphere. Radius of curvature, R. Distance from pole to center. Principal focus, F. Point where parallel rays meet or appear to meet. Focal length, F. Distance from pole to focus. Important, F equals R by 2. For concave mirrors, focus is real. For convex, it is virtual. To find the position and size of image, we use the mirror formula. 1 over versus plus 1 over U equals 1 over F. Where U equals object distance, usually negative in sign convention. V equals image distance. F equals focal length. Negative for concave, positive for convex. Magnification M equals minus versus over U, which also equals height of image over height of object. If M is positive, erect image. If M is negative, inverted image. Sign convention, new Cartesian. All distances measured from pole. Distances in direction of incident light are positive. Opposite are negative. Heights above principal axis positive. Below negative. Let's solve a quick example. An object is placed at 30 cm in front of a concave mirror of focal length 15 cm. Find image position and magnification. Given U equals minus 30 cm. F equals minus 15 cm. Concave. 1 over V equals 1 over F minus 1 over U equals 1 over minus 15 minus 1 over minus 30 equals minus 1 over 15 plus 1 over 30 equals minus 1 over 30. So V equals minus 30 centimeters. M equals V over U equals minus 30 over minus 30 equals minus 1. This means real, inverted, same size image at the center of curvature. Refraction is the bending of light when it passes from one transparent medium to another due to change in its speed. Light travels fastest in vacuum or air, slower in water, even slower in glass. When light goes from rarer to denser medium, air to glass, it bends towards the normal and slows down. From denser to rarer, it bends away from normal. Laws of refraction. 1. Incident ray. Refracted ray and normal lie in same plane. 2. Snell's law. The ratio of sine of angle of incidence to sine of angle of refraction is constant for a given pair of media and color of light. N equals sin I over sin R. Refractive index. Refractive index N equals speed in vacuum divided by speed in medium. For a glass slab, the emergent ray is parallel to incident ray but laterally displaced. Lenses are transparent optical devices made of glass or plastic bounded by spherical surfaces. 2 types. 1. Convex lens. Converging, thicker at center, used in cameras, projectors, magnifying glasses, spectacles for long-sightedness. 2. Concave lens. Diverging, thinner at center, used in spectacles for short-sightedness. Lens formula. 1 over versus minus 1 over U equals 1 over F. Power of a lens P equals 1 over F. When F in meters, SI unit, diopter, D, 1D equals 1 per meter. Power of combination of lenses. P equals P1 plus P2 plus. For convex lens, F is positive. For concave, F is negative. Always remember the sign convention carefully. For mirrors, F negative for concave. For lenses, F positive for convex. Object distance U is always negative. This is very important for numericals in exams. Practice ray diagrams, they carry marks. Real-life applications are everywhere. Concave mirrors, solar concentrators, shaving mirrors, dentist mirrors, vehicle headlights, convex mirrors, rear view mirrors, wider field of view, lenses, correct vision defects, cameras, projectors, telescopes. The human eye also has a natural convex lens. Summary of key formulas. 1. Mirror. 1 over versus plus 1 over U equals 1 over F. 2. Magnification M equals minus versus over U. 3. Lens. 1 over versus minus 1 over U equals 1 over F. 4. Power P equals 1 over F. In meters. 5. Snell's law. N1 sin I equals N2 sin R. 6. F equals R by 2 for mirrors. Practice question on screen. A convex lens has focal length 20 centimeters. At what distance should the object be placed to get a real image of same size? Find power of lens. Answer. At 40 centimeters from the lens. Power equals plus 5 diopter. That's all for light, reflection and refraction. Practice NCERT questions in previous year papers. If you understood everything, give this video a thumbs up. Subscribe for more Class 10 Science one-shots. Comment your doubts or which chapter next. See you in the next video. Bye.